Hi guys, good morning, good afternoon, or good evening. So welcome to our online class again. This is Berluian Gautani signing in. So this is our fourth session. Okay, and for the rules, I only want two things from you guys. Number one, listen. Number two, so focus. Okay, so before we start, let's say prayer. Loving Lord, we praise and glorify your name. We're humbly asking for your guidance throughout the day. May we have the wisdom to understand today's online class. We're thankful that today we are alive and well, that we are given another chance to partake with the fullness of life. Most especially to have the opportunity to do good and be of service to mankind. Amen. Okay, let's have our battle cry. Okay. Kalhayan ako. Gustong gusto kong matuto ng wasto. Caloocan High School, mahal na mahal ko. Kalhayan ako. Ayoko sa sigarilyo. Ayoko sa alak. Ayoko sa damo. Ayoko sa bato. Kalhayan ako. Di ako siga. Di ako bully. Di ako basagolero. Kalhayan ako. Mayapa akong tao. Sa Caloocan High School, walang kalat, walang nagkakalat, at walang pakalat-kalat. Okay, so before we start, let's have first a short review regarding our previous lesson, which is about the definition of an arithmetic sequence. Now, what is again an arithmetic sequence? Okay, you may answer via messenger. Okay, very good. So, arithmetic sequence is a sequence which has a common difference. Okay. Let's have some examples. Okay, let's say for example we have 1, 3, 5, 7, and let's say we have 10, 5, 0, negative 5, and so on. Okay, so an arithmetic sequence has a common difference. The question is how to find the common difference. Okay, very easy. Preceding term minus the previous term. So 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2. So if you notice, all the differences are the same. Therefore, the common difference is 2. The symbol for the common difference is small letter d. Okay, let's have the second. So again, to get the common difference, preceding minus the previous term. So 5 minus 10 is negative 5. 0 minus 5 is negative 5. Negative 5 minus 0 is negative 5. Therefore, the common difference is negative 5. Okay, so what have you noticed between the two sequences aside from their common difference? Very good. So the first one has no ellipsis, while the second one has ellipsis. So there are two types of arithmetic sequence. We have the finite and we have the infinite. Okay, so this 3 dots is called ellipsis, which means that it continues infinitely, while this one has no last term because it has no ellipsis. Okay, and also before we proceed, take note of the following. A sub 1 means first term, n is the number of terms. Okay, and a sub n is the n term, any unknown term of the sequence. Okay, so n designates the position of the term. So if we have a sub 2, it means the second term, a sub 3 means the third term, a sub 4 means a fourth term, and so on and so forth. So that's it for our short review. Let's start with our new lesson. Okay. So our lesson for today is about the nth term of an arithmetic sequence. Okay. Given the arithmetic sequence 3, 5, 7, 9, find the following. Number 1, next 3 terms. Number 2, 10 term. Number 3, 1,000 term. Number 4, 100,000 term. I'll give you a minute to answer. Time is up. Okay, so the next 3 terms are 11, 13, and 15. Why? Okay, so to determine the next 3 terms, you must know the common difference, right? So again, to get the common difference, subtract the preceding by the previous. So 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2. So D is equals to 2. So just add 2 here. So 9 plus 2, 11 plus 2, 13 plus 2. We have 11, 13, and 15. How about the next 10 term? Oh, sorry. So 21. Are we correct? Let's see. So this is the first, second, third, fourth, fifth, sixth, seventh. So add 2, we have 17. Add 2, we have 19. So this is the 9th. And therefore, the 10th term is 21. Okay? Question? Okay. How about the 1,000 term? So now, I think maybe because it's too far, right? So mahirap mag-add, no? Add hanggang 1,000 term, hanggang 100,000 term, baka maubos yung oras. So finding the next 3 terms or the 10th term of an arithmetic sequence is easy if we know the common difference. We can find any term of an arithmetic sequence easily if we use the rule in finding the nth term of an arithmetic sequence. So we can find any term of an arithmetic sequence if we use the rule. So what's the rule? Okay. So we can find the answer on the next slide. Okay, observe. So we have the sequence 3, 5, 7, 9. So the positions of each term is 1, 2, 3, 4. So a sub 1 is 3, a sub 2 is 5, a sub 3 is 7, a sub 4 is 9. So what is the nth term? So the arithmetic sequence above starts with 3. The common difference is 2. You can use the first term and the common difference to write the rule for finding the nth term. So the a sub 1 again is 3. So to get the next term, we add the common difference, right? So in symbol, a sub 1 plus d. Okay, substituting, the first term is 3. Common difference is 2, so 3 plus 2 is equals to 5. Next, the third term. So in symbols, the second term is a sub 1 plus d. Okay, so we'll add again another d on the second term to get the third term. Second term plus d to get 7, or 3 plus 2 plus 2 equals to 7. Now for the fourth term, we'll add 2 for the another common difference. Okay, to the third term to get the fourth term. So this is the third term, right? The third term plus d, or 3 plus 2 plus 2 plus 2 is equals to 9. Now I want you to find 10th term. How? Observe the pattern. Okay, so you all know that we can combine d, right? So d plus d, we have 2d. Therefore, the third term is a sub 1 plus 2d, right? Okay, same literal coefficient, we can combine. Okay, so on the fourth term, we have 3d, right? So 1 plus 1 plus 1, we have 3d. So we have a sub 1 plus 3d. So this is the rule for the third term, the rule for the fourth term. And now what is the rule for the 10th term? What have you noticed? Okay, so a sub 1, nothing changes, right? So as is lang siya. And doon sa d, you notice here, we're looking for, or if we are in the third term, d is multiplied by 2. If we are in the fourth term, d is multiplied by 3. So what's your analysis? Okay, very good. So just subtract 1 on the end, then multiply it to d. That's it. So therefore, a sub 10 is equals to a sub 1 plus 10 minus 1 is 9 d. So this is the rule for the 10th term. Okay, so using the rule here, so a sub 1 is 3, 9, because 10 minus 1 is 9 times d, which is 2. So 9 times 2 is 18 plus 3 is equals to 21. Now what is the nth term? Okay, very good. The nth term is equals to a sub 1, and then subtract 1 here, so n minus 1, and then multiplied by d. So following the pattern, the nth term of an arithmetic sequence is a sub n equals to a sub 1 plus quantity n minus 1 count quantity d. Okay, let's have our examples. So find the indicated term of the arithmetic sequence. So what is the 16th term of the sequence 4, 8, 12, 16, and so on. So the step 1 is to find the common difference. So preceding minus the previous term, just like that. Okay, so 8 minus 4, or we're adding 4, therefore the common difference is 4. Now step 2, write the rule to find the 16th term. So write the rule to find the nth term. Next is to substitute 4 for a sub 1, first term, 16 for n, and 4 for d. Next, simplify the expression. Remember the PEMDAS, follow that. So we start in the parentheses. So 16 minus 1 is 15, multiplied by 4 is 60 plus 4. We have 64. Therefore, the 16th term is 64. Question? Okay, question. Let's have the next example. So what is the 25th term given the a sub 1, negative 5? The common difference is negative 2. So write the rule to find the nth term. Next is to substitute negative 5 for a sub 1, 25 for n, and negative 2 for d. Okay, then PEMDAS, start here in the parentheses. So 25 minus 1 is 24. Okay, and then multiplication, 24 times negative 2 is negative 48, plus negative 5 is equals to negative 53. Therefore, the 25th term of the sequence is negative 53. The third example. Find the indicated term of the arithmetic sequence 11, 5, negative 1, negative 7, comma, and so on up to the 60th term. Therefore, we're looking for the 60th term. So the step 1 is to find the common difference, right? Okay, so negative 6 is the common difference. 5 minus 11 is equals to negative 6. Negative 1 minus 5 is equals to negative 6. Negative 7 minus negative 1 is negative 6. So the common difference is negative 6. Step 2, write the rule to find the 60th term. Okay, and then substitute 11 for a sub 1, 60 for m, and negative 6 for d. Then subtract 60 minus 1, 59, times negative 6, we have negative 354, plus 11, we have negative 343. Therefore, the 60th term of the sequence, arithmetic sequence, is negative 343. Now, last example, find the indicated term, the arithmetic sequence. So the first term is equals to 4.2. The common difference is 1.4. Now, what is the 12th term? Ulit-ulit lang naman, di ba? So, first, write the rule to find the nth term. Then, substitute 4.2 for a sub 1. Okay. 12 for n. Okay. And then, d is 1.4. We have, okay. Next, 12 minus 1 is 11 times 1.4. We have 15.4 plus 4.2. Then add, we have 19.6. So therefore, the 12th term is 19.6. Question, guys? If you have questions, just type in Q on our group chat. Okay? So no question. Let's proceed to our practice exercises. Find the indicated term of each arithmetic sequence. Number 1, what's the 23rd term of the sequence negative 4, negative 7, negative 10, negative 13, and so on. Number 2, the 40th term of 2, 7, 12, 17, and so on. Number 3, the 7th term if the first term is equals to negative 12 and the common difference is 2. Number 4, what's the 34th term given the first term as 3.2 and the common difference as 2.6. I'll give you 10 minutes to answer that. And time starts now. Okay, so we're done. Time's up. Send me the picture of your solution individually, okay? DM, not on our group chat. Okay, so let's check your work. Okay, so the first the answer on number 1 is negative 70. On number 2, 197. On number 3, we have 0. And then the answer on number 4 is 89. Okay, now no erasures should be done from the original. Okay, sinend niya sa akin yung first picture na solution, so dapat ganun din. Okay, so if you got perfect, type in 4P. P means practice. Okay, if you got 3 correct answers, type in 3B. If you got 2 correct answers, type in 2B. If you got 1 correct answer, type in 1B. And if you got 0, type in 0B. Okay, so give me a minute. I'll count those who pass. So you pass the practice exercise if you got 2 and up. Okay, so 90% of you passed the practice exercises. So we'll proceed to our quiz. So again, I'll give you 10 minutes to answer the following. Same procedure. Okay, time is up. Send me now the pictures of your solutions individually, not on our group. Okay, let's check your work. Check your own. So the answer number 1 is negative 85. Number 2 is 342. Number 3 is 5. Number 4 is 39.4. Okay, so if you got perfect, type in 4Q. Q means quiz. If you got 3 correct answers, type in 3Q. If you got 2 correct answers, type in 2Q. If you got 1 correct answer, type in 1Q. And then if you got 0, type in 0Q. Now, question? So give me a minute to count those who passed. Okay, so 95% of you passed the quiz. So to those who failed, don't worry, we'll have another session. See you at 7 p.m. today. Okay, later. Okay, so for your homework, find the indicated terms of algorithm sequence. Number 1, the 15th term of negative 12, negative 1, 8, 17, and so on. Number 2, the 21st term of 2, 13, 24, 35, and so on. Number 3, the 12th term of 1 half, 3/4, 1, 5/4, and so on. And then number 4, the 27th term of 6, 5 and 1/4, 4 and 1 half, 3 and 3/4, and so on. So it's the end. See you again next time, guys.